seeing flat pictures, but how about seeing pictures in 3D, in 3 different dimensions? So with that, I'm going to be presenting 3D image reconstruction, design, development, and deployment. So I'd like to introduce my team. First of all, Mr. Nguyen Zap, not here, and Mr. Nguyen Tu, not here, but I have Sam and Dr. Lei Song here, even though I didn't put them on the slide. So what are we going to be talking about? I'm going to be talking about understanding 3D image reconstruction, the development framework, results, and the future of 3D image reconstruction. So you might be wondering, what is 3D image reconstruction? Simply put, 3D image reconstruction is just a process of capturing the appearance of a real object and creating a 3-dimensional view of the object. We can see an example here. That's good. Okay. Okay, so first off, I would like to note that this application is actually designed to work on an Android device. How does it work really? When you have the app on your phone or any Android device via camera, you take 360 images. Actually, you're not the one taking it. The app does that for you. And stitch together these images and create a blur-free picture. Finally, you get a 3D image. This is the major challenge facing 3D image reconstruction is image stabilization. Simply put, you have a blurred image and you want to make it very clear. That is the challenge facing this application. But we've been able to solve the problem with certain algorithm. I won't want to bore you with all the computer science. So, in pictures, this is the app here. We're taking a picture of a car. This picture here is a little blurred. You might not notice because of the projector. But this is a clearer picture of this. How do we solve this? The algorithm is just comparing, out of the 360 images we take 2 images close to each other, and the app brings out the best quality picture for us to use. Now, we'll get to us seeing the demo, but first of all, let's talk about the framework used to design this. Of course, we used an iterative model, which simply means we develop, test, go back if there are any bugs, and keep going in the sample until we get a stable version of the app. The framework. We use the Android Studio to develop in Java, Eclipse SDK in Java and C++, then the OpenCV plugin, which actually helps us create the image in 3 dimensions. And of course, I mentioned Java, C# as a language, C++ as the languages, and XML. XML is something like HTML, but doesn't talk more of presentation, just data storing. Then the deployment. We've deployed and tested this app on almost all major Android devices, from Android 2.0 to later. So it should and it will work on most modern day Android devices. One interesting thing about this application is it works with two sensors. Most people might not know, but each Android device or modern day device has inbuilt sensors in them. The accelerometer and gyroscope. These sensors are used to correct and guide the user how he should take a picture around the object. Now, the accelerometer we use that to tell the user he's going too fast around the object, while the gyroscope takes the position of the user and how he should take the picture at a particular time. Now, this is an example of the accelerometer and gyroscope, the positioning of the phone at any given point in time, whether he's rotating, the user is rotating around in circles or placing the phone in the wrong direction. Okay, as I mentioned earlier, this device, these sensors helps the user to know when he's going in the wrong direction while taking the picture, and if he has placed the phone in the wrong direction or the phone is tilted to a wrong angle while taking a picture. This is an example of what the accelerometer and gyroscope does. This is a picture taken in the right direction. When it's in the right direction, you find green. The app alerts you that you are correct with these green lines by its side. Still, the app is tilted to about 28 degrees, so you're still in the correct angle while taking a picture. But when you go 48 degrees, beyond 45 degrees, it alerts you with the red line and tells you you're in the wrong direction. The picture quality will not be actually good. So the deployment, as I mentioned already, we've used it, we've tested and deployed this app on major Android devices. Asus and Samsung are the major ones we've tested it. And I'd like to show you the results of this app. I've been talking about it for a while now. So, actually, I'm going to show you a demo of what the app can do. So, this is a picture already taken with this application. Now, the front view looks like a flat picture, but actually it's not a flat picture. It's a 3-dimensional picture. I wish it was. So this is what the app does. It gives you a 3D image or all-round image about it. That's why we call it CAD 360. So what is the future and the applications of this? We can use this app for people in car sales. You can use it for online shops where you can display your products and show the customer all-round image of your products, car insurance, or insurance companies, and also in other fields, police investigations and all that. You can take a whole image of a room and view it later and find out things that are there and things that you could use. The future, we are hoping to use drones to take larger picture of larger areas. And so what did we talk about? We've looked at 3D image reconstruction. We have seen how it's done and the frameworks we use to develop this application. And we look forward to having this application used in different fields. Thank you for listening.